Welcome to Math Tutorials. In today's lesson we're going to take a look at solving radical equations. And first let's remind you what a radical equation looks like. Here's an example. Solve square root of x plus 5 minus square root of x minus 3 equals 2. It's got two square roots or radicals, so it's what we call a radical equation. The steps for solving radical equations are as follows. First you isolate the most complicated root if there's more than one. If there's only one, then you just isolate the root that you have. But if there's several, you isolate the most complicated one. Then you raise each side of the equation to the appropriate power that eliminates the root. So if you have a square root, you square both sides to get rid of it. If you have a cube root, you raise each side to the third power. If you have a fourth root, you raise it to the fourth power, and so on. And then after doing that, if you still have a root in the equation, then rinse and repeat. Do the same thing over and just isolate what's left and then use powers and eliminate that root. When you've gone through that and you've wiped out all the roots in the equation, you're going to end up with a polynomial equation, and you're going to use what you know from before for solving those. And then finally, if you end up squaring both sides of an equation, you could be creating extraneous solutions. Those are solutions that look like solutions, but they're actually not. And so we have to check and make sure that the numbers that we get actually work. And that's the last step. Okay, so let's go to it. Here's our problem again. And so the first step was isolate the most complicated root. Here, they're basically just as complicated. One has an x plus 5 inside, one has an x minus 3. So we're just going to go ahead and isolate it. Now, I want to make a point here that this is one of the first mistakes that people make in these problems is if they haven't done their homework, if they haven't paid attention in class, they don't remember that the first step is isolate the most complicated root. So what you see people do is this. They take their equation that looks like this and then they say, let's just, they kind of remember vaguely that squares undo square roots. So they say, let's just square both sides. And then they say, okay, well this is going to be square root of x plus 5 squared minus square root of x minus 3 squared equals 4. And then these squares wipe out the roots, so it's x plus 5 minus x minus 3 equals 4. Or some people think there might be parentheses in here, but it doesn't really matter because it's wrong. And if you wonder, well, where did they go wrong? They went wrong in the very first step, or maybe it's the second. This step right here, it's wrong already. And the reason is because they took a square here and they passed it to each of these terms, squared each one with a minus in between, and you can't do that. You can't pass a square through a plus or a minus. You can't pass a power through a plus or a minus. If you think back to your exponent rules, remember if you have a times b to the nth power, then you can pass the power to each piece. A to the n, b to the n. That's correct. If you have a over b in parentheses to the n, same story. You can properly pass the power through to each piece. But if you have a plus or a minus, you cannot. Okay, you remember this from Algebra 1. A plus b to the n is not a to the n plus b to the n, and a minus b to the n is not a to the n minus b to the n. And you know this. You know that you have to FOIL it out to get the right answer. So when you take something like x minus 2 squared, it's not x squared minus 2 squared. It's not x squared minus 4. You can't just pass this square through the minus in the middle. What you have to actually do is write it out twice and FOIL. X minus 2 times x minus 2, and when you do that, it's x squared minus 4x plus 4. Okay, so watch out for that. I call it passing a power through a plus or a minus. You cannot do that. So right away in the very beginning of this problem, that's a dangerous thing that a lot of people fall into. But if you memorize the steps, you won't do it, because the steps say, number 1, isolate a root. And this, if you're doing the squaring process, you're not even obeying that first step. Okay, so that's what we want to start with, the first step. So we add square root of x minus 3 to each side. Okay, these cancel. So our equation is square root x plus 5 equals 2 plus square root of x minus 3. Okay, so back to our steps. Isolate the most complicated root, and then raise each side of the equation to the appropriate power to eliminate the root that you just isolated. Get rid of that root that you just isolated. In our case, it's a square root. So how do we get rid of a square root? Right, we square. So take this and square, take this and square. Okay, we square both sides of the equation. Now the nice thing is on the left side, when you square a square root, they just cancel each other. So this is just going to be x plus 5. But what happens on the right? Well, once again, our warning is do not pass that power through the plus. You've got a plus here, 2 plus a root. I cannot pass this square to each of those. Okay, it's the same rule we just looked at over here that I crossed out on the right side. I have to FOIL that out. So I'm going to write it 2 plus square root of x minus 3 times 2 plus square root of x minus 3. And then I'm going to have to FOIL that all out. Okay, so x plus 5 equals, here we go, x, 2 times 2 is 4. 2 times square root of x plus 3 is 2 square root of x minus 3. But here's another 2 square root of x minus 3. Also positive. And then here's the toughest one for most people. Square root of x minus 3 times square root of x minus 3. Well, when you take square root of x minus 3 times itself, the roots cancel. You're squaring it by multiplying it by itself, and the roots cancel. So this is just x minus 3. So plus x minus 3. That's FOILing out that root expression there. Okay, now let's combine a few terms. So on the left we've got a 4 and a minus 3. 4 minus 3 is 1. There's a plus x. And then over here there's 2 square root of x minus 3 plus 2 square root of x minus 3 is 4 square root of x minus 3. Okay, now a lot of people see this and they sort of give up. They're like, oh, okay, I went ahead and I squared both sides and, oh no, it didn't just fall into place. I'm stuck. What do I do? And, well, the short answer is go back to your rules. If you don't know what's going on here and it looks different to you, go look at the rules. What did the rules say? Okay, raise each side to appropriate power. We did that. Rinse and repeat. Okay, what does rinse and repeat mean? It means repeat the first 2 steps. Isolate the root and use powers if there are still roots in your equation. Well, that's our situation, right? We still have a root in our equation. We've got this square root of x minus 3 there. So if you look, we have progressed. If you compare this to the original equation had 2 square roots. By doing our isolation and squaring, we've now gotten rid of one of them. There's only one root in our equation. So we have made progress, believe it or not. And then our next step is going to be isolate this root and do the same thing, and we're going to wipe it out. And then there'll be no more roots. Okay, so isolate. That was the key. Isolate. So get rid of these other terms. Subtract the 1, subtract the x from both sides. X's cancel. 5 minus 1 is 4. The 1's and the x's cancel. So 4 equals 4 square root of x minus 3. And since the 4 goes into 4 nicely, I'm going to divide both sides by 4. Okay. If this didn't go nicely, I wouldn't do it, but it goes nicely. So we get 1 equals square root of x minus 3. Alright, so we've isolated the root, and then remember our mantra is isolate and then use the power, square to get rid of it. So we're going to square both sides now, because that's going to wipe out the square root. Okay, 1 squared is 1. On the right, the square kills the root, so it's just x minus 3. And you see now it's not a root equation anymore. Now it's a polynomial equation. And in our case, it's actually specifically a linear equation. Single powers of x. So you just isolate x, add 3 to each side, and you get 4 equals x. Okay, now that's our potential solution. Since we did square both sides, there's the possibility of extraneous solutions. So we need to take that and go back to the original equation and check it to make sure that it really works. So let's do that. And then if it checks out, then that's our solution. So here we go. We go back to the original equation. Square root of x plus 5 minus square root of x minus 3 equals 2. Everywhere there's an x, put 4, because we think that's our solution. So 4 plus 5 minus square root of 4 minus 3 equals 2. We'll do a little simplification. Square root of 9 minus square root of 1. Square root of 9 is 3. Square root of 1 is 1, so it says 3 minus 1 equals 2. That's true. It checks out, so that is our solution. X equals 4, or you could write in set notation a 4 inside the braces. Okay, so that's the biggest thing with radical equations or root equations. So there's two main things to watch out for. The biggest one is passing powers through pluses and minuses. You cannot do that. That is by far the most common mistake that my students make. And then the second one, it's a little bit more minor, but it's still a mistake. A lot of times people forget to check the solutions at the end. And sometimes the solution that you got doesn't check, and they end up with giving solutions that don't actually work. So those are the two things to watch out for in these kinds of problems.